Okay, this question here, it says sides of triangles are given below. We have these triangles here, all the sides are mentioned. Determine which of them are right triangles. We have to see to it which one is a right triangle. In case of a right triangle, write the length of its hypotenuse. In case we find them as a right triangle, we have to give the length of its hypotenuse. Okay, first of all, we have to see which one is a right triangle. We know that if these are right triangles, then in a right triangle, hypotenuse square is equal to base square plus height square. Second thing is, we know that hypotenuse is the longest side. In these three sides, 25 is the longest. So if I take this as hypotenuse and put into this format, then 25 square should be equal to 24 square plus 7 square. And if that doesn't work, it means this is not a right triangle. 25 square is equal to 24 square plus 7 square. So this gives me 625 equals to 576 plus 49. 625 means 625 is equal to this side. Both the sides are equal. It means this is a right triangle and hypotenuse is 25 centimeter. This one here, this is the longest side. So if this is 8 square is equal to 6 square plus 3 square, this will be a right triangle. Let's see. 64, 36 plus 9. 64 is not equal to 45. It means this is not a right triangle. So I'll write not right triangle. This one here, longest side is this. So if 100 square is equal to 80 square plus 50 square, this will be a right triangle. Let's see. Not equal, so not right triangle. This one here, this is the longest side. This is 169 equals to 144 plus 25. So here 169 is equal to 169. So this is a right triangle, means hypotenuse is 30 centimeters. Alright. This question here, it says PQR is a triangle right angled at P. PQR, it's a right triangle here, right angled at point P. And M is the point on QR. M is the point on QR such that PM is perpendicular on QR. PM is perpendicular on QR means this angle here and this angle here both are 90 degrees. Show that PM square is equal to QM into MR. Okay, QPR, right angle at. As per theorem, in a right angle triangle, perpendicular drawn from the vertex of right angle on the hypotenuse will give us two right triangles, and both these right triangles are similar to each other as well as similar to the big triangle or whole triangle. So I'll write here, since triangle PQR is a right triangle, right angle at point P, and PM is perpendicular to QR. In that case, this triangle here and this triangle here would be similar, and both of them would be similar to big triangle. Okay, we have three triangles, PQR, this and this. Let's pull all of them apart. This is the big triangle PQR, right angled at P. This is Q. This is R. This little triangle here, right angled at M and Q and P. Q is common in both. Okay. This is right angle. This is right angle. This triangle here is right angled at M. This triangle here is also right angled at M, R and P here. Okay. Now, triangle QPR would be similar to triangle QMP would be similar to triangle PMR. Let's take triangle QMP and triangle PMR. In QMP and PMR, since both of them are similar, QM over PM will be equal to PM over RM. Corresponding sides will be equal to QP over PR. Let's keep this aside for a while and let's work on this here, this piece here. Here, QM into RM will be equal to PM into PM, then PM square. So now I have PM square equals to QM into RM or MR. We can write this way also. So PM square is equal to QM into MR. PM square is equal to QM into MR. That's what we have to prove. Alright. This question here. ABD is a triangle. ABD is a triangle right angled at A. Right angled at A. AC is perpendicular to BD. Means AC is perpendicular to hypotenuse. Show that AB square is equal to BC into BD, AC square is equal to BC into DC, AD square is equal to BD into CD. Okay. First thing first, we know that as per this question, this triangle and this triangle, they would be similar, and both of them would be similar to the third triangle because ABD is a right angle triangle. A here is right angle, and as per the theorem, when we draw a perpendicular from right angle on the hypotenuse, then that perpendicular gives two triangles on both the sides. Those two triangles are similar to each other and similar to the whole triangle, the big one also. Means this triangle, they are similar, and both of them are similar to the third one also. So let's pull the triangles apart. We have three triangles here. First one, the big one. Second, the little one. This. And third, the bigger one. This one here. Okay. This is DA, the big triangle, right angle at A. The little one, right angle at C. This would be D because D is common in both. In this triangle and the big one, D is common, so this will be D and this will be A. This one here again, right angled at C. This would be B because B is common in this and the big one, and this would be A. So I have DAB, DCA, ACB. I'll write here triangle DAB would be similar to triangle DCA would be similar to triangle ACB. DAB, DCA, ACB. All are similar. Let's take triangle DAB and triangle ACB. Okay. I have AB square equals to BC into BD. To prove BC, BD. BC is in this triangle, BD is in this triangle, and AB is in this triangle, AB is in this triangle. That is why I have taken this and this triangle. Okay. Ratio of corresponding sides would be equal. So I'll write dA over AC would be equal to dB over AB will be equal to AB over CB. Okay, let's keep this aside. Let's take this one. dB into CB, dB into CB equals to AB into AB, AB square. I can write this as AB square equals to BC can be, CB can be BC and DB can be BD. AB square equals to BC into BD. Done? This one here, same way, let's draw three triangles exactly like this. Here I have AC square equals to BC into DC to prove. Okay. This has AC and this has AC. This has BC and this has DC. I'll take this triangle and this triangle. I'll write triangle DCA is similar to triangle ACB. In that case, DC over EC would be equal to DA over AB will be equal to CA over CB. Let's take this and this, means DC over AC equals to CA over CB. AC into CA will give you AC square equals to DC into CB. I can write it as BC into CD. Proved. Third one, let's draw the same triangles like this. Again, I have AD square. AD is here and AD is here, so I'll take triangle DAB is similar to triangle DCA, means DA over DC would be equal to DB over DA will be equal to AB over CA. Let's take this. DA into DA is DA square, or AD square equals to DB can be as BD and DC can be as CD. So AD square is equal to BD into CD. Done? This question here, it says ABC is an isosceles triangle. ABC, it's an isosceles triangle. Right angle at C. Right angle at C. It means ABC is an right angle isosceles triangle. Prove that AB square is equal to 2AC square. I'll write here triangle ABC is an isosceles right angle triangle. Right angle at C. In that case, AB will be hypotenuse. Since AB is hypotenuse, AB would be longest side. In that case, AB cannot be equal to AC or BC. Now, when AB cannot be equal to AC or BC, in that case, ABC, being an isosceles triangle, will have AC equals to BC. I'll write, since ABC, triangle ABC is an isosceles triangle, I can take AC equals to BC. Now, ABC is a right angle triangle. In that case, AB square will be equal to AC square plus BC square. AC square I leave as it is. BC square I can write as AC square, since AC is equal to BC. So in place of BC square, I'll take AC square. So AC square plus AC square will give you 2AC square. So I have AB square equals to 2AC square. AB square equals 2AC square. That's what we had to prove. Done? I'll take this equal to this like this. This question here, it says ABC is an isosceles triangle with AC equals to BC. ABC is an isosceles triangle where AC is equal to BC. If AB square is equal to 2AC square, prove that ABC is a right triangle. It says AC equals to BC and it gives AB square is equal to 2AC square, and AC is equal to BC. Then AB square, in place of 2AC square, can I write it as AC square plus AC square? Okay. Can I take one of the AC squares as BC square, since AC is equal to BC? Now I have AB square equal to AC square plus BC square. Now, as per the Pythagoras theorem, if a square of one of the sides is equal to the sum of a square of other two sides, in that case, angle opposite to the first side would be 90 degrees. So I'll write, in that case, as per Pythagoras theorem, angle opposite to AB will be 90 degrees. This gives angle C equals to 90 degrees. This here would be 90 degrees. When one of the angles in triangle ABC is 90 degrees, triangle ABC is a right triangle at angle C. That's what we had to prove. Prove that ABC is a right triangle. We have proved ABC as a right triangle. Alright. This question here, it says ABC is an equilateral triangle. This is a triangle ABC. All the sides are equal, means this is an equilateral triangle of side 2A. All the sides, length of them is 2A. Find each of its altitudes. These are the altitudes. Now, this is ABC, A, B, C. Let's take these altitudes as D, E, and F. This is a equilateral triangle. Now, in case of an equilateral triangle, altitudes are perpendicular bisectors of their sides. Means this is 90 degrees, this is 90, and this is 90. Okay. It means this gives me AFC, BEC, CDB as right angle triangle. Okay. Then it says all the altitudes are equal to each other as well, means AF will be equal to CD will be equal to BE. It means if I find out length of any of these altitudes, it will give me length of all three altitudes. It says perpendicular bisector, means this will be A, this will be A, this is A, 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 A. So if I have to find out length of AF, I can write it as, since triangle AFC is a right angle triangle, in that case, side opposite to right angle would be hypotenuse. AC square will be equal to AF square plus FC square. AC is how much? 2A. This will be 2A whole square equals to AF. AF I have to find out. AF square plus FC will be A square. So this is 4A square equals to AF square plus A square. Means AF square will be 4A square minus A square. So AF square will be 3A square. So AF would be root 3A square. This can be A root 3. Now AF is equal to BE equals to CD. All will be equal to A root 3. Done. This question here, it says, prove that the sum of the squares of the sides of rhombus is equal to the sum of the squares of its diagonals. I have ABCD as a rhombus here. I have to prove AB square, BC square plus CD square plus AD square is equal to AC square plus BD square. Now, since this is a rhombus, AC and BD, they are the diagonals. They are intersecting at point O. Now, in case of rhombus, its diagonals bisect each other at 90 degrees angle. First of all, they bisect at 90 degrees, means all these angles here, all four angles, each one of them is 90 degrees. Second, it says bisect means OA will be equal to OC and OB will be equal to OC. Okay. Now, I'll write here triangle AOB, triangle BOC, triangle DOC, and triangle AOD. All will be right triangle at point O. Okay, second point here is AC is equal to OA plus OC. So if I write AC square, means squaring both the sides, this would be OA plus OC whole square. So AC square will be equal to OA square plus OC square plus 2 into OA into OC. I can take it as OA square plus OC square plus 2 into OA into OA, since OA and OC, they are equal. Okay, I'll write OA is equal to OC. So this will be OA square plus OC square plus 2OA square. So 2OA square means OA square plus OA square. OA square I leave as it is, and this OA square I write as OC square, since OA is equal to OC. So now I have AC square is equal to OA square plus OC square plus OA square plus OC square. Now, same way, BD square will be equal to OB square plus OD square plus OB square plus OD square. You take BD equals to OB plus OD, square both the sides, will give you, from the same process, BD square is equal to OB square plus OD square plus OB square plus OD square. Okay, now let's take this as 1 and this as 2. Let's add 1 and 2. Alright, adding 1 and 2. That will give me AC square plus BD square equals to OA square, OC square, OA square, OC square. I'll write here OA square plus OC square plus OA square plus OC square plus OB square plus OD square plus OB square plus OD square. 1, 2, 3, 4, 5, 6, 7, 8. 8 components, and AC square plus BD square. Now, as I said, AOB, BOC, DOC, AOD, all are right angle triangle. AOB, BOC, DOC, AOD, all are right angled triangle at point O. It means AB square will be equal to OA square plus OB square. OA square plus OB square will give you AB square. So I'll write it as AB square. I'll write here, since AB square is equal to OA square plus OB square, same as with BC square is equal to OB square plus OC square, CD square is equal to OC square plus OD square, and AD square is equal to OA square plus OD square. So OA square plus OB square gives you AB square plus OB square plus OC square gives you BC square. BC square. So this is done. This is done. OC square plus OD square gives you CD square plus CD square. OA square plus OD square. OA square plus OD square gives you AD square. OA square plus OD square gives you AD square. So now I have AC square plus BD square equals to AB square plus BC square plus CD square plus AD square. That's what I had to prove. Sum of squares of the sides of rhombus, sum of squares of sides of rhombus is equal to the sum of squares of diagonals, equal to the sum of squares of diagonals, AC square plus BD square. Proved? Done? This question here, it says O is a point in the interior of a triangle ABC. We have this triangle ABC where O is a point inside ABC, where OD is perpendicular to BC. OD is perpendicular to BC. OE is perpendicular to AC. OE is perpendicular to AC. OF is perpendicular to AB. OF is perpendicular to OB. What we have to prove here is OA square plus OB square plus OC square minus this is equal to this. And then we have to prove AF square plus BD square plus C square is equal to A square plus CD square plus BF square. Okay, first thing first, let's connect O to A, O to B and O to C. Let's not be confused with this point of intersection O of all these perpendiculars as circumcenter for this triangle. All these are perpendiculars but not the bisectors. If OF, OE and OD, they are perpendiculars, which they are, as well as if they are bisectors for their sides also, in that case this point O will be circumcenter for ABC. However, in this case OF, OE, OD, they are perpendiculars, however they are not bisectors. In that case this is not circumcenter. Okay. Now OF is perpendicular to AB. It means AOF can be taken as a right angle triangle. Right angle at F. FOB, DOB, COD, COE, AOE. All these 1, 2, 3, 4, 5, 6 triangles can be taken as right angled triangle. So I'll take a first AOF. I'll write in triangle AOF. In triangle AOF, right angled at point F will give you OA as hypotenuse. So I can write OA as OA square is equal to AF square plus OF square. This triangle is done. Let's take up this one. Here also I'll write OB square is equal to BD square plus OD square. This is triangle BOD. Okay, this is done. Let's take this triangle where OC is hypotenuse. So OC square is equal to CEE square plus OE square. This is from triangle EOC. Okay, these three triangles are done. Let's take this one and this one also. In triangle AOE, I'll write triangle AOE. Again, OA square can be equal to AE square plus OE square. Now let's take this triangle BOF, where OB square is equal to BF square plus OF square, BF square plus OF square. Now this last triangle, this is triangle BOF. In this triangle, OC square, CD square plus OD square. This is a triangle COD. So all these 6 triangles I have covered. Now let's add this here. OA square plus OB square plus OC square is equal to AF square plus OF square plus BD square. Can I write this as OA square plus OB square plus OC square minus, I take OD, OE and OF this side, so this will be minus OD square minus OE square minus OF square equals to, what is left is AF square plus BD square plus CE square. OA square plus OB square plus OC square, OA OB OC minus OD OE OF, OD OE OF, AF BDC, AF BDC. So this is done. Okay. Now let's sum this up. This will be, now if you see, OA square plus OB square plus OC square is equal to this. OA square plus OB square plus OC square is equal to this. It means this piece here can be equal to this piece. I can write as I have OF square here, OF square here can be cancelled, or you take this OF square this side, this becomes negative. OF square minus OF square will give you 0. That's why we can cancel it. OD square cancelled. OE square and OE square cancelled. What I'm left with is AF square plus BD square plus CE square equals to AE square plus BF square plus CD square. AF square plus BD square plus CE square. AF square BD square CE square equals to AE square CD square BF square BF square. So this is also done, proved. So done. This question here, it says a ladder 10 meters long reaches a window 8 meters above the ground. Find the distance of the foot of the ladder from the base of the wall. Easy one. We have, say, this wall where I have a window here, and this window, it says, is 8 meters above the ground. This is 8 meters. Then it says a ladder 10 meters long reaches the window. So if this is the window and this is the ladder, it says find the distance of the foot of the ladder. This is the foot of the ladder from the base of the wall. So I have this, I have this, I have to find out this distance. So I take this as A, this point here, this as B, and this is C. Since this is a wall, I take it as straight wall, 90 degrees. So ABC would be a right angle triangle. I'll write it. Since ABC is a right triangle, 90 degree at point B, in that case, AC square will be equal to AB square plus BC square. AC square is 10 square, AB square is 8 square, BC square I have to find out. So this will be 100 minus 64 equals to BC square, means 36 is equal to BC square. So BC would be root 36, which is 6. So this distance, base of the wall to the foot of the ladder, would be 6 meters. Alright? This question here, a guy wire attached to a vertical pole of height 18 meters is 24 meters long. It says this guy wire is 24 meters long, attached to a pole which is 18 meters high, and has a stake attached to the other end. Okay, means one of the ends of this wire is attached to the other end of this pole. How far from the base of the pole should the stake be driven so that the wire will be taut? Okay, I have this pole which is 18 meters high, and I have a 24 meters long wire attached, one end here and one end is like this, attached to the other end of the pole. Now it says how long this stake should be dragged that this wire becomes stretched like this. This is the pole, and if this end of this wire is already attached, and if I drag this wire, it should be like this, completely stretched. I take it as A, B, C. This is 18 meters. This is 24 meters. I need to know how much is this. It means how much I need to drag this wire from this point till the end so that this is completely taut or stretched. Okay. This is a vertical pole, so this will be 90 degrees. So I'll write AC square will be, AC will be hypotenuse opposite to the 90 degrees angle. AC square will be equal to AB square plus BC square. AC is 24 meters, so 24 square, AB is 18, 18 square plus BC square. So this will give you 576, and this will give you 324 plus BC square. So this will be 576 minus 324 equals to BC square. This gets you 252 equals to BC square. So BC is root 252. So this can be written as 2 into 2 into 3 into 7. So which will give you 2 into 3 root 7, which is 2 into 3 is 6 root 7. That's the answer here, 6 root 7 meters. Alright? This question here, it says an aeroplane leaves an airport and flies due north at a speed of 1000 kilometers per hour. At the same time, another aeroplane leaves the same airport and flies due west at a speed of 1200 kilometers per hour. How far apart will be the two planes after 1.5 hours? Okay, so first of all, I'll write distance covered by plane 1, I'll say going north, would be 1000 kilometers per hour speed into 1.5 hours, 1500 kilometers. Now distance covered by plane 2 going west, this is going at 1200 kilometers per hour. In 1.5 hours, this will go 1800 kilometers. Now let's put it this way: plane 1 heading north, 1500 kilometers. Plane 2 heading west, 1,800 kilometers. We need to know how far apart will be the two planes after 1.5 hours. Means, what is this distance here? If I take this as A, B and C, this is 90 degrees. I need to know this. So this will be hypotenuse because ABC is a right angle triangle. So AC square will be AB square plus BC square. This gives you, this is 549,0000. So AC would be 549,0000 root. Now let's solve this root here. This can be written as 3 into 3 into 61 into 100 into 100. Okay. These two 3's will come out as 3. These two hundreds will come out as 100. 61 stays inside. So this is 300 root 61. So the distance between this plane headed north and distance between this plane headed west, 300 root 61 kilometers. That's the answer here. Alright. This question here, it says, two poles of heights 6 meters and 11 meters stand on a plain ground, standing straight. If the distance between the feet of the poles is 12 meters, find the distance between their tops. I have two poles, which is, this one is 6 meters and the second one is 11 meters. So I'll write it as pole 1, pole 2. If the distance between the feet of the pole is 12 meters, means this distance here is 12 meters. This is 6 meters. This is 11 meters. Find the distance between the tops. This distance I have to find out. Okay. I put it this way. A, B, C, D, E. Straight poles. So 90, 90. If this is 12 meters, this will also be 12 meters. BC will be equal to ED. Okay. This is 6. Complete is 11. So this will be 6. And this will be 5. 6 plus 5 is 11. I have to find out this one here. So I'll write this way. BE is 6 meters. AD is 11 meters. And AD is equal to AC plus CD. 11 is equal to AC plus CD is 6 meters. I'll write here. BE is equal to CD. So AC would be 5 meters. And then write here BC is equal to ED. If ED is 12, BC will also be 12. So I have this 12, this 5. I need to know this. I'll write triangle ACB is a right angle triangle, 90 degree at point C. In that case, AB square will be equal to AC square plus BC square. AC is 5, 5 square. BC is 12, 12 square. So 25 plus 144, which is 169. So AB would be root 169, which is 13. So this will be 13 meters. So distance between the tops would be 13 meters. Alright. This one here, it says D and E are points on the sides CA and CB respectively. CA and CB, we have D on CA, E on CB. Of triangle ABC, right angled at point C. Prove that AE square plus BD square, AE square plus BD square is equal to AB square plus DE square. Okay. This is right angled at C. It means AB will be hypotenuse. Alright. in triangle ABC, AB square will be equal to AC square plus BC square. Let's take this as 1. Then write in triangle DEC, DE square will be equal to DC square plus EC square. Let's take this as 2. Okay, now let's take triangle. Alright, in triangle AEC, AE square will be equal to AC square plus EC square. Let's take this as 3. Now let's take triangle. In triangle DBC, BD square will be equal to DC square plus BC square. Number 4. Now you see, if I add 3 and 4, I'll write adding 3 and 4. This will give me AE square plus BD square equals to AC square plus EC square, this, plus DC square plus BC square, DC square plus BC square. Now AC square plus BC square is equal to AB square. So I'll write AE square plus BD square is equal to AC square plus BC square is AB square plus DC square plus EC square, DC square plus EC square is equal to DE square. DE square, I'll write here from 1 and 2. DC square plus EC square is DE square, DC square plus EC square, so DE square. Now you have AE square plus BD square is equal to AB square plus DE square. AE square plus BD square is equal to AB square plus DE square. That's what we have to prove. Done? Okay, this question here says the perpendicular from A on side BC of triangle ABC. This is triangle ABC and perpendicular drawn from A to BC intersect BC at point D, means AD perpendicular to BC, and then it says DB is 3 times of CD. We have to prove that 2AB square is equal to AC square plus BC square. Okay. First of all, let's concentrate on this piece here. It says DB is equal to 3CD. Okay, I'll write here BC is equal to CD plus DB. Now BC can be equal to CD plus DB is 3CD. In place of DB, I'll write 3CD. So BC is equal to 4CD. If I square both the sides, BC square will be equal to 16CD square. Okay, let's take it as 1. Let's move back to this one here. I'll write in triangle ADB. This is right angle on point D. It means AB would be hypotenuse. So I'll write AB square is equal to AD square plus DB square. Okay. Let's take AB square equals to AD square plus DB square can be written as 3CD whole square, means AD square plus 9CD square. Now let's split this 9CD square and write it as CD square plus 8CD square. CD square plus 8CD square gives you 9CD square. Now AD square plus CD square, AD square plus CD square is what? AC square. AC square plus 8CD square. I'll write here in bracket AC square is equal to AD square plus CD square. Okay, now it says AB square is equal to AC square plus 8CD square. Multiply both the sides by 2. I'll write multiply both sides by 2. So this will be 2AB square and this will be 2AC square plus 16 CD square. 8 CD square multiplied by 2 gives you 16 CD square. This is now 2AB square equals to 2AC square plus 16 CD square is equal to BC square. Now I have proved 2AB square is equal to 2AC square plus BC square. 2AB square is equal to 2AC square plus BC square. Done? This question here it says, in an equilateral triangle ABC, this triangle ABC here, which is an equilateral triangle, D is a point on side BC, D is this point on side BC, such that BD is 1/3 of BC. Means BC is 3 times bigger than BD. We have to prove that 9AD square equals to 7AB square. Okay, these questions are more of brain twisters. Okay, ABC is an equilateral triangle. Let's draw a perpendicular from A to BC like this. Let's name this as E. Okay, since ABC is an equilateral triangle, so perpendicular drawn from A to BC will be a perpendicular bisector for BC. Means BE would be equal to AC. I'll write here, since ABC is a equilateral triangle, then AE over BC by construction will give BE equals to EC. Okay, we already have BD equals to 1/3 of BC. Now let's take triangle ADE. Alright, in triangle ADE, this is a right angle triangle, right angled at E. AD square will be equal to AE square plus DE square. AD is the hypotenuse, since this is opposite to the 90-degree angle. Okay, let's keep AE square as it is, plus DE square. DE can be BE minus BD. I can write this as BE minus BD square. Okay, AE square plus BE can be half of BC. BC over 2 minus BD is already 1/3 of BC. This is BC over 3. Okay, let's give one more twist. This is equilateral triangle, so AB, AC, BC all will be equal. So in place of BC, can I take AB? I'll write this as AB over 2 minus AB over 3 whole square. You solve this, AE square plus 3AB minus 2AB whole square means AE square plus AB over 6 square will give you AB square over 36. So this is equation number 1. Let's make equation number 2. Let's take triangle ABE. I'll take triangle ABE, which is also a right angle triangle. Right triangle. In here, AB square can be equal to AE square plus BE square. AB square equals to AE square plus BE can be taken as half of BC. BC over 2 whole square. AB square is equal to AE square. BC can be equal to AB. AB over 2 whole square. So this gives me AB square equals to AE square plus AB square over 4. Let's take this as equation number 2. Now I have two equations. First one is here. AD square is equal to AE square plus AB square over 36. AB square is equal to AE square plus AB square over 4. Let's take equation number 1 and 2. AD square is equal to AE square plus AB square over 36, and this is AB square equals to AE square plus AB square over 4. Let's solve them. Minus, minus, minus. It is gone. What I have here is AD square minus AB square equals to AB square over 36 minus AB square over 4. Okay. AD square minus AB square equals to AB square minus 9AB square. This gives me AD square minus AB square equals to negative 8AB square over 36. This will give you 36 AD square minus 36 AB square equals to negative 8 AB square. Okay, so 36 AD square is equal to negative 8 AB square plus 36 AB square. 36 AD square is equal to 28 AB square. So 36 AD square is equal to 28 AB square. Let's divide both the sides by 4. I get 9 AD square equals to 7 AB square. That's what we had to prove here. 9 AD square is equal to 7 AB square. Proved. Done. This one here it says, in an equilateral triangle, I have this equilateral triangle, prove that 3 times the square of one of its sides is equal to 4 times the square of one of its altitudes. It says this is equilateral triangle. All these are altitudes, so they all are 90 degrees. And most importantly, this is equilateral triangle. It means all these altitudes will be perpendicular bisectors. Alright, since ABC is equilateral, couple of conditions. AB will be equal to AC will be equal to BC, and BE will be equal to CD will be equal to AF, and all of them are perpendicular bisectors. Third, AE would be equal to EC will be equal to FC will be equal to BF will be equal to AD will be equal to BD. So these are certain conditions we need to see when we are dealing with equilateral triangle. Okay, now these all are 90 degrees. It means AFC, AFB, all these triangles are right angle triangles. Let me take triangle. I'll take triangle AFC. In this, AF square would be equal to AC square minus FC square. AF square would be equal to AC square minus FC square, or AC square is equal to AF square plus FC square, same thing. Then triangle, let's take it as 1. Now let's take triangle ABE, and that BE square will be equal to AB square minus AE square. Let's take it number 2. Now let's take triangle BDC, in that CD square will be equal to BC square minus BD square. Number 3. Now let's add all of them. I'll write add 1, 2 and 3. So this will give me AF square plus BE square plus CD square equals to AC square minus FC square plus AB square minus AE square plus BC square minus BD square. AF, BE and CD all are equal. So AF square, BE square, CD square. In place of that, I can write AF square plus AF square plus AF square, or BE square, BE square, BE square, or CD square, CD square, CD square. Let's take any of them. I'll take AF. So it will be AF square plus AF square plus AF square will give me 3AF square. Okay. Here I have AC square, I have AB square, and I have BC square. AC, BC, AC all are equal. In place of AC square, AB square, BC square, let's take all AC square. So this will give me 3AC square. What I'm left with is minus FC square minus AE square minus BD square. 3AC square minus common be FC square plus AE square plus BD square. Okay. Now 3AC square minus FC square can be written as BC over 2 whole square. AE can be written as AC over 2 whole square. And BD can be written as AB over 2 whole square. Now 3AC square minus BC, AC, AB, again all are equal. So in place of BC over 2, AC over 2, AB over 2, I'll take all of them as AC over 2. So this will be AC square over 4 plus AC square over 4 plus AC square over 4. 3AC square minus, this will be 3AC square over 4. We can solve it here also because there is no space left there. So 3AF square equals to you solve this gets you 12AC square minus 3AC square over 4, okay, which is 9AC square over 4. This is 3AF square equals to 9AC square over 4, which can be 4 into 3 is 12AF square equals to 9AC square. Divide both the sides by 3. This gives you 4AF square equals to 3AC square Now you see what this says here is 4 times of any of the altitude square is equal to 3 times of any of the sides square. 3 times the square of one side is equal to 4 times the square of one of its altitudes. 4 times of square of altitude and 3 times of square of side. They are equal. That's what we had to prove. Done. This question here it says, take the current answer and justify. In triangle ABC, AB is 6 root 3 centimeter, AC is 12 and BC is 6. The angle B is what? See, from the given information, the only angle you can check is 90 degrees. Any other angle you cannot verify or check from the given information. So let's try for 90 degrees, which will make this triangle as right angle triangle. Okay. Suppose I take angle B as 90 degrees. In that case, AC would be hypotenuse. AC squared should be equal to AB squared plus BC squared. AC squared is 12 squared. AB is 6 root 3 squared. BC is 6 squared. So 144 equals to, this will give you 6 into 6 into 3 plus this will give you 6 into 6. So this is 108 plus 36, which is 144, means this side is equal to this side, means AC square is equal to AB square plus BC square. Now, you know the theorem, it says square of one side if equal to the sum of a square of other two sides. In that case, angle opposite to the first side would be 90 degrees. Here, AC square is equal to AB square plus BC square, means opposite to AC we have angle B. This would be like this. A, B, C, AC is 12, AB 6 root 3 and BC is 6. AB and BC can be interchangeable. You can name it as this way also. In that case, this will be 6 root 3 and this will be 6. But hypotenuse will not change, which will give you the angle opposite to you, which is 90 degrees. Here, AC square is equal to AB square plus BC square. It means this is 90 degrees. Alright?